All right, so we're on 12.2, worksheet 2. Yesterday we estimated limits using graphical and numerical methods. Today we're going to use a little more algebra. So we're going to talk about polynomial and rational functions and a little bit about infinity as well. Doesn't matter how you find the limit on the final, you are more than welcome to use the graph. All right, these are just some basic things you'll go over next year, but a constant, if you just said y equals 6, obviously the limit everywhere is 6. The limit of an identity function like x equals 3 or some y equals 3x, like some kind of a linear function that's continuous, you will get the answer by plugging the value in. All right, in calc, you're going to learn all these properties where you can like add two limits. You can do that by separating the limit at each point and all this crazy business, okay? We're just going to not go over those today. Use the properties of limits to evaluate each limit. So this is a continuous function. If I just look at that equation, I should know in my head that's just a parabola opening up. So it's continuous. There's no holes because there's no denominator. So to find the limit, I'm more than welcome to just put a 4 in there. So 4 squared minus 6 times 4 plus 3 is negative 5. Okay? As long as we know it's continuous. This is true of every function that is continuous. Okay? If it's a polynomial function, you can just plug the value in to find the limit. It's the same of rational functions. You can just plug the value in as long as it doesn't make the denominator 0. If it makes the denominator 0, then we have to do something different. These are called well-behaved functions, guys. Continuous functions, such as polynomial functions, are considered well-behaved. Isn't that nice? Their mom said they're very well-behaved. Since limits of these functions can be found by direct substitution. Okay, the limits of functions that are not well-behaved over their entire domain, in other words, they're not continuous, there's some kind of a break, can still be found as long as the value does not make the denominator 0. So this is on your worksheets because we can look at this. What can you tell me about this just by glancing at this equation, guys? Can you draw back into your brain and think about what you know about this equation? Nothing? If I graph it, what's it going to look like? The exponent power that's the highest is a 4. And it has a negative 2 in front. Anybody? It could cross the x-axis up to 4 times. Because it's a negative 2 out front, what's the end behavior doing? Both ends are... Degree 4 is like this. And with a negative, both ends are down. Anybody remember this at all now? Okay. It's a continuous function, though, so we can apply direct substitution. It wanted the limit at negative 2. Notice this was a two-sided limit, okay? So they substituted it in. Oh, can someone help me? This would be 16 times negative 2. This would be negative 8 times 3. Negative 43. Did anybody get that? Probably wrong. I think it's negative 43. There's a lot of parentheses there. Someone get that? No, Zoe? Okay. I'm going to go with this is right, but I think I did it right. All right, guys. Continuous or not? It's just a parabola, right? That opens up. So it's continuous. We can find the limit. We could graph it, but we could also just put in a 3 here. 2 times 3 squared minus 5 times 3. You can do that on your home screen. You can graph it and put a 3 in, trace 3. You could go to the table. Anybody tell me what that's going to be? Okay, guys, can we just do these quick and be done for the day? 9 times 2 is 18 minus 15 is 3. Okay, can I put a 5? Now, a square root function of a cubic, I don't really know what that looks like. Okay, there actually are some undefined places because you can't square root negative numbers. But is it okay to put a 5 in here? Does it come out all right? Yeah, it does. It says 125 minus 4 would be 121, and that would be 11. And I graphed it here just to show you at 5, it is defined as 11. So there's the limit. Okay. It is customary to describe the resulting fraction in indeterminate form. For example, right now, if I put a 1 in here, I would get 0 over 0. Okay? But if we were to graph this, remember from yesterday? If you're coming from the left and you're coming from the right, what y value is this getting closer and closer to? 2. Okay? If we factored the top, remember I did this yesterday? We could divide out that factor, it leaves this, and then we were finding the limit at 1, so if we put a 1 into the remainder here, 1 plus 1 would give us a limit of 2. So if you evaluate the limit of rational function and reach the 0 over 0, you should try to simplify by factoring and divide out the common factor. Okay, so we're good with that. This one could be factored. It gets down to x minus 5. So if you put in a negative 4, you get negative 9. Now, it was undefined there, so I graphed it. And I checked values close to negative 4, and they all rounded to negative 9. Is everybody good? Because you have to be able to do this. There's one on the final that has this, okay? This one would factor. You could divide this out. It's the limit at 4, so you're putting a 4 in here. 4 minus 5 is negative 1. I'm going quick because nobody seems to be paying attention. Okay. Can I put a negative 2 in outright? Makes the denominator 0. Does the top factor? Then what can I do? Okay. And then how do I find the limit? You don't have to do it that way. On the final, you can type this in, go to the graph. It's going to be undefined at negative 2, but if you check a little to the left and a little to the right, it's going to be at 5. Everybody okay that it's all right to do it either way? All right. Can I do direct substitution here? Is it defined at negative 4? Yes, it is. I'd have 1 over negative 4 plus negative 4, which is negative 5/4, I believe, or negative 1.25. That's fine. That's where the limit is. Number 6. Can I just, what does this graph look like? Yeah, it's a parabola opening down. So I can just put it in because it's continuous. Be careful when you put this in, though. It's the opposite of 2 squared plus 5 times 2 minus 1. So this would be 4, and then it would become negative 4. So I think you get 5. They all have a limit of 5 today? I feel like I've written that 4 times. Okay. Can I put a 0 in here? No. This is a mess. Let's do this one by graphing. I'll show you that you can do it algebraically, but what would we need to be able to do it by graphing? Can everybody please do this one? Humor me. you need an extra parenthesis around the top, right? You could put parentheses around the bottom, but it won't matter there because it's just an x. All right, so on your calculator, go to y equals, and it was the extra parenthesis, and then the quantity, thank you, 3 plus x quantities squared minus 9, and then close that extra parenthesis, and then divide by x. Okay. Wow, all that, and it looks like a line. What are we trying to find the limit at? Okay, look what happens when I put 0. It's undefined. Okay, but can I figure out what's really close? What's really close to 0? 0.0001. Okay, what's it close to? Okay, what's just to the left of it? Of 0? Yes. Negative 0.0001. Is that also close to 6? So what's the limit? 6. Okay. The algebra would have looked like this. Can anybody square 3 plus x for me? Please don't tell me it's 9 plus x squared. 3 times 3 is 9. You'd have to do this, right? So you'd get a 6x, then a plus 9. Then there's a minus 9 that was at the back, and it's all over x. What happens? What? Whoa, half hour. What should that be? Yeah. Yeah, I don't know either. Okay, now what happens though? These go away. Now can I cancel an x? Please don't cancel an x because Miss Gupta will shoot you next year. Yes, it's killing kittens. Remember, you can't cancel unless you can factor it out. So take an x out. Now can I cancel an x? Now I can cancel that guy, and I'm left with 6 plus x. If I put the 0 in there, I get this 6, okay? So it's algebraic, but I would have done it by graphing because I didn't want to do all that algebra. So I probably would have made a mistake. All right, these are limits to infinity. And it's the fact is, can you predict them knowing the degree? So end behavior, all right? If you have a polynomial function, the limit is infinity or negative infinity as it approaches infinity, as it increases or decreases without bound, and it depends which way, okay? So we learned all this. If you have a leading, no, this says if you have a positive integer, so you have x to a 4 or x to a 3. This means both ends are up, right? This is talking about left end. So it's up if it's even, left end is down if it's odd. Okay, this is all stuff we really already know. All right, so as you go off to the left on a degree 5, which you could do on your calculator, but a degree 5 is odd, so it's this or maybe this, I don't know. But what's the left end doing here? It's going down, okay? So it actually doesn't have a limit, but we would describe it as negative infinity. Oh, anyway, I wrote it there. Everybody good? This says you can divide each term by the highest power of x, every single term, okay? Only when you're finding a limit to infinity. This is just end behavior. There's a fancy way of doing this that you'll learn in calc, where you divide everything by an x. So if I divide 4x by x, I just get a 4. If I divide 5 by x, I get 5 over x. On the bottom, I divide 8x by x, I just get 8, minus 3 over x. Now, why was that helpful at all? Well, if x is going towards infinity, this is going to approach 0, and this is going to approach 0. So we're left with 4 over 8, which is leading coefficient over leading coefficient. Do you remember when we learned that? When they have the same weights, remember, not bottom heavy, top heavy, equal weights? Then the end behavior is just leading coefficient over leading coefficient. So it's 1/2. It's just an end behavior rule. It's a fancy way you'll do it next year. All right. This one, we learned it as bottom heavy. Do you remember what bottom heavy approached? Well, they divided everything by an x cubed, and they end up with 6 over x, which is approaching 0. This is approaching 0. There's a 3 in the denominator, but this is approaching 0. So it's just approaching 0. These are just the rules for bottom heavy. Okay? It will approach 0. All right? Top heavy, bottom heavy, equal weight. Degree 5, degree 5. So what was our rule? Leading coefficient over leading coefficient, which is 4. So it should approach 1/4. All right, I graphed it with extra parentheses in. I got a really funky little picture here. Can you see that? It's doing some little fun stuff in here, okay? But on the left end, as you scroll out to the left, look what happens. It's just 1/4, okay? All right, we have talked about this. 1 over infinity is approaching 0 because the bigger the number in the denominator, the smaller the fraction will be. So we're just going to do these real fast. What's the negative cubic look like? You can graph it if you need to. What does that look like, though? Cubic is normally like this, but a negative means what? Flipped, so it's looking like this. So what is the left end doing? Going up towards infinity. So they would, in calculus, write, it is approaching infinity. But I need you to understand that that's really not a limit. Okay? 5 divided by a really big number is going to approach 0. Okay? Anybody remember this? Equal weight? That's finding vertical asymptotes. Yes. This is not bottom heavy. If it was, it would be approaching 0. You could graph this, guys. You could put this in on divided by this. Okay? I just want you to make sure that you get that you don't have to use your, what was it? 6x plus something on the top? Minus 1 divided by plus 7. Thank you. Okay, they want to know what's happening out on the far end, so I'm actually going to go straight to the table. Are we going positive infinity or negative infinity? This was positive infinity, so I'm going to put 9, 99, 9999. What's it approaching, guys? Yeah, 0.6. Does that look familiar? Leading coefficient over leading coefficient. Okay. So you can do it without knowing the rules. Just use your graph. This is asking about far left. Can you visualize what's this doing on the far left if it's a degree 3 with a positive coefficient? Going up or going down? Yes, it would look like this. So you would say it's going towards negative infinity. All right, number 12 is bottom heavy. So what's this going to approach? 0. I put it in the calculator. The graph was really interesting here. Had a goofiness going on. But in the end, it says 6 times 10 to the negative 5th. That's 0.00006. So it's approaching 0. And so that one does have a limit. The limit, Here, what shape is this? Degree 4. Both ends up because it's a positive coefficient. So what's it going to approach? Very good, infinity. On the far right, this graph is going up, yes? Because it's even with a positive leading coefficient. Okay, equal weight. So what's this one going to approach? Leading coefficient over leading coefficient is 1/2. I graphed it, put in big numbers. Is it approaching 1/2? Okay, you could put 0.5. All right, look at this mess. Okay, you take your dose, it goes out of your system. You take your dose, it goes out of your system. Take your dose, it goes out of your system. But apparently some is remaining in her system. It's building up as she takes more, okay? Tamika takes 2 milligrams of her asthma medicine. The graph shows the amount left in her system after D days. Find the limit. What is this? Haven't done any of these today. What is this asking? Yes, as it approaches 3 from the left, it is a one-sided limit. Okay, so we get to x equals 3, which is here, coming from the left. What y value is it approaching? 2. So this answer is 2 right here. As you approach 3 from the right, this is also a one-sided limit. As here's 3 again, but coming from the right, the graph would be doing this. So it's approaching the y value of 4. Everybody good? Those are one-sided limits. And then you have the assignment. If you want to do these together, I'm going to stop the recording, but